This conference will now be recorded.
This thing just switched around my screen, but okay. I never, just when I have the thing all ready to go and to click on what I need, it just said, no, I'm going to change what you're seeing. All right, I got it. So I'm sorry I did not get nearly as far as I had hoped to on attestation. Had a whole bunch of conflicts, but at least I got to the point where we can have a discussion because we need to just make some decisions as a group as to how to proceed. So I started on so last week. By the way, thank you for your comments on the white paper and the presentation about the white paper. I've revised it to incorporate your suggestions. The main ones were to include sort of colored arrows to follow the four different sample scenarios, and the other was to add some references to real attacks that demonstrate some of the threats that were described in there. Probably the best reference of all that is most relevant for this, when the paper will be published probably Thursday or Friday, I'm guessing, assuming we pass the incubation committee review meeting. There's a reference that I added that has a whole boatload of attacks on smart cards. Now, I know we're not working on smart cards, but so many of them are absolutely relevant to what we're doing. It's just a different piece of gear than what we have, but the attacks are the same. So anyway, when you see the final paper, you'll see that reference in there. One of the best places to look for those, by the way, there is a professor at University of Cambridge, Ross Anderson, who's famous, notorious, whatever, for hacking into systems. He's also been an expert witness in many trials where, for example, a bank has declared that someone had fraudulently used an ATM card, or had not even fraudulently, but had kept depleting their account. And the customer said, no, I didn't do any of that stuff. And the bank said, you must have, because our smart cards are perfect and they cannot be hacked. And you couldn't have, no one could have possibly stolen your card or hacked a card that looked like your card. And so Ross Anderson has testified in a number of those cases to demonstrate to the bank and protect the customer, saying, yea, verily, these things can be attacked, and here's how we did it in our labs. So really good reading, link to a lot of those hacks. So on to attestation. Who do we have in here? Yep, good. Okay. So the first thing I did was I started on the easiest protocol, which is the one that would be done in the factory. And the first thing that I came across was we differ ever so slightly from TPMs in our world, because in the world of TPMs, you have the origin of the universe starts with the endorsement key, which is really a decryption key. Although it says endorsement, it's not really for signing, it's for encrypting or decrypting. And then on top of that, there is the attestation key, which can be generated. But the origin of the universe is with the endorsement key that comes from the TPM manufacturer and the certificate for it. What I think we have is a slightly different model. I think what we have is a device ID, a unique device ID that identifies this device among all the many in the world, and its own attestation key. So its identity is separate from what it uses to attest with, right? One is I am this device, serial number, blah, and and manufactured by this particular vendor. The attestation key would be different, and that is I'm this device identified by my identity, but I'm running this particular firmware, maybe using these keys and so forth. So there's separate uses. And, in separating keys, good practice, good key hygiene is to keep those two separate. And the goal in this manufacturing step is to get a certificate from the factory, from the manufacturer, from the vendor manufacturer. The vendor, I'm sorry. So I came up with questions here. So this protocol assumes that this operation is done in a secure facility, right? So you don't have a CA that's off in the boonies that you're trying to connect to over a network. It's right there with the device, because until we get to this point, the device has no credentials, right? It has only what it says it is. And so how it doesn't have a root of trust, it doesn't have anything. And this is sort of the birth of the device. So to try to establish a secure channel with it, I think is difficult unless someone out there has another idea. The assumption I have here is that it's done in a secure facility. So let me stop talking, and we have some questions, but let's stop and talk about that so far.
Is the flow you have described there, is that something you created, or is this an existing credential, I guess, kind of setup it's in use right now? Is it like a kind of a standardized flow?
No, this one is something I came up because it's not even really a flow. I mean, there's not like there's any kind of chit chat and proof of identity back and forth. There's no nonsense. There's no nothing. It assumes everything connecting the two is secure, which may not be a valid assumption. But the question is, what else can you do in a manufacturing facility before the device knows even who it is or who it's talking to? This is the origin of the universe.
Right.
So one thing that could be done in this is that the root of trust of the device is still in there from the standpoint of immutability, right? So assuming that you have some kind of faith in the immutability of that device, of the ASIC hardware and ROM image, and that kind of thing, you could leverage what's, in the device authentication proposal that's been, pushed out by Intel from the standpoint of looking at the measurements of the firmware that's running.
Okay.
It might help here, and that's kind of one of the reasons that's in that spec. But outside of that, now I think you're, so you show a couple of public keys being passed. Is there a reason why you have two? I guess I'm not following why that is.
So the one is essentially identity. It doesn't necessarily have to be a key. I mean, it can be just a value. In fact, the identity key is, the identity does not have to be, the dev ID is not a key, but do we need a key pair that says, if I'm going to talk to you about who I am, I will use this. And if I'm going to talk to you about what I'm running, I'll use the attestation key. Now,
I see. That was for your thought of like separation of the roles. Never mind. Okay, now I'm following.
Right. Right. So we don't have to do that. This is just, like I said, this is a proposal, and we're starting from somewhere that we can critique.
Okay. Well, what are folks' thoughts on the measurement idea? And just so maybe I'll throw a little background in there in case it's not familiar. The measurement concept, what it would do is provide you absolute values of what the firmware, of hash values effectively, right? So just message digests of what firmware is currently running inside the device, and those would be put into hardware-backed registers that can't be modified without a reset effectively of the device. It would force the device to go back to its immutable root of trust.
So those are measured. Well, you wouldn't be measuring the immutable part because that's the part doing the measuring. So
Right.
it would be measuring the mutable parts of firmware that are initially placed on the device. Yeah.
Correct.
Okay, and then as far as a protocol goes, you couldn't distinguish it from any other device. I mean, you couldn't distinguish it from any other one like it, right? Because it's all the ones in that product family are going to have the same measurements, right? Or they should. Well, unless you've got some kind of uniqueness in each one that gets sucked into that measurement.
Right. No, the intention of the measurement was not to be fragile in that regard.
Yeah.
And it was supposed to reflect, an absolute. So if you had a class of devices, and you wanted to go and just look to see from an absolute perspective, what are those devices executing? And you could check it across a class of devices, not necessarily have it unique per device. And that's, the unique per deviceness would come along with this. The TCG specification, the DICE specification is kind of where it appears the industry's headed here, right?
Yeah. So let's think out loud here. If you do send measurements off to the CA, then I still assert, maybe I'm dreaming here, but I think that we still need a secure channel, right? Because what if you have a bad guy trying to get a certificate? If they
Yeah, we
haven't
use a secure channel. I posted a couple things in chat on how we do it with our hardware. So we do manufacture them in a secure facility, and we put our certificates on there. And then we have our customers go through a pairing process. But at any time, if one of our devices is lost or stolen, we can blacklist it.
All right, I'm reading what you have in the chat. So you also do the secure facility. So this operation is done not through like a secure protocol. It's done in a secure connection.
Right. We actually have our own factory that we build these in, and so it's all done in the secure facility. And then we do the pairing over the secure protocol.
Yes. Yeah, exactly.
So in that concept, there wouldn't be some sort of like Elaine was talking about, some sort of already baked in key or something like that you would depend on. Right? This is more of just having the facility be secure and then having the device generate some sort of secure value. Right?
Yeah, so the approach I think here is the gates, guards, and guns approach, right? That those two devices, the CA and the attester device, together are protected inside some physically secure facility that's protecting their communications.
Yeah.
All right. Is everybody okay with going with that approach? Is anybody objecting to going to that approach?
It seems like that approach requires you to know who the customer is at the time of manufacturing. Like, how would you is there any way to mass manufacture and not immediately have a customer for the product?
Yeah, we do mass manufacture. We don't know who the customer is until the time of assignment. So when we ship it is when we assign that particular device to them. So we have to keep track of which device has which keys on it.
Yeah, and
And
for
how
us,
you-
that's possible to do.
Yeah, how would you keep them secure between being manufactured and assigned, though? Are you just assuming physical security?
Correct. And then if one escapes custody, then we can blacklist it.
Well, I guess I'm questioning as to why does it have to be customer assigned at the
Right.
time of manufacturer? So it seems like if you had them, like Elaine's showing here, if you had the device ID or identity key that was signed by the manufacturer, then you could just ship it, right? And then
Yeah, I think we're ahead of ourselves. I think when we're going to ownership already, and this
Right.
is not ownership.
Yeah, I think it depends on the use cases as well. Ours is a particular use case that may not fit for everyone.
So I think you could do either one. Seems like you could sign as a manufacturer, or you could sign on behalf of, someone else wants to sign their devices and independently SKU them. I think either way you could do that. I don't see why this approach prohibits either one. But I would agree with the comment that we don't want to. I think in general as an industry, we probably don't want to stock a customer-specific X09 certificate for everybody on the planet, but you shouldn't have to.
Yeah, let's talk about the let's see. I have some questions to ask about this particular piece, and then we can go on to ownership, because I think that Nate already stepped in ownership. He's a good straight man. All right. So, first question: is everybody okay using the this IDEV ID standard? And I honestly, I've read it a few times, and I'm getting them all mixed up. I thought that the DICE, which produces the Dev ID standard, includes a whole bunch of things to produce the device ID, which is the firmware and some kind of generated key combined to come up with this device ID, and a random number, or, some randomness. But is that, do I have it right? And do we want to use that as our standard? Are we just going to say, okay, go look up IDEV ID, implement that, and stick that in your device?
Yeah, I think that's better than leaving it up to the vendor.
All right, so we'd say device, whatever the device ID here is, some vendor unique device ID. And
Yeah, I
how,
think that keeping
yes?
it more flexible so that it's someone can use DICE, but someone can just simply use a either self-generated or provisioned private key. I think maybe more flexible for different manufacturing flows.
The problem I see with device ID injection, I mean, I agree, some manufacturing is really hard, and even on some parts, it's probably hard to self-generate. But as a whole, injection means that there's processes in place that people can tamper with, or people can just make mistakes. And I could see running 1,000 ASICs at a subcon and make 1,000 identical parts because someone forgot to do something during, I don't know, a switch over at a subcon.
Yeah, I mean,
So I think the recommendation really ought to be that you self-generate a value, and that you don't take it from outside.
For sure, I think that if that is possible, that should be definitely preferred way, right? To self-generate the private key. But I wonder if at this point in time should we exclude a provisioned key, or no, given that, for example, they would need to be enough documentation and information about the methodologies used, would that still be acceptable?
I guess if you knew it was going to be produced in a secure facility and you audited that facility, then maybe as a receiver of this component, you could convince yourself that the process is safe. But I think for general market, it's kind of ugly. I mean, for example, in a lot of cases, the parts are programmed at a subcon and they're produced at another facility and they're shipped out to that subcon. It would be very easy just to pick up a reel of chips that haven't been programmed yet, and take them somewhere and go do whatever you want to with them, and then release them into general supply.
Yeah, you have to assume the entire supply chain is perfect.
Yeah, and I think that's the bad road you go down, is you end up in a place where it's kind of like the ballots in a state election. You got to make sure that the train of trust is established throughout. Otherwise, you don't know the integrity of that chip. So,
I mean, I guess one question I have is, I mean, are the overall goals here to provide best practice guidelines? You should do this for these reasons and so on, or is it, you must do this to get, I guess a certification, or I don't know, or a badge that it's OCP secure or something, where it's a must to do it a certain way. And so we probably want to think about what, where is it that we want to have must statements, and probably like with interoperability, between the platform root of trust and a PCI card. Obviously you need standards and stuff that have to be done, but when it comes to other things, that distinction between guidance and requirements is something I guess you should keep in mind.
It would be nice if in an infrastructure that a platform root of trust could detect how that ID got generated in the first place, right? Is it self-generated or was it injected? And then the value of that would be then is that a particular data center or implementation could make decisions about whether they want to trust those parts or not. Although I think in practice, they're probably going to get with their suppliers and ask them the question, do you inject or do you generate? And then they just say, well, we don't accept parts that inject. Oh, yours is the only one of that type on the planet. I guess we'll accept it. Please go fix that though. Right?
That's an interesting thought. If we trusted it to report, we could force them to include a field, even in the certificate, that says whether it's injected or self-generated.
Yeah, I mean, detection would be. I mean, ultimately, detection would be nice, right? Because you can't. I don't know that you could distinguish. If I handed you an ASIC and you responded appropriately, I don't know that you could distinguish how the value got in there. You just have to trust somebody about how they did it. So
and part of the process also, like even if the device has the key self-generated through dice, for example, if there are parts of, for example, debug capability that like if you don't set some end of manufacturing bit, then you can still see like the secret that is used for generating the key over JTAG, then that's kind of also defeats the purpose, right? So there are multiple kind of places where this can fail either way, right?
Yeah, if I drop the part into debug mode, then I could certainly clone the part. I could make thousands of chips. The back end of that is that you end up, you fall back on, well, for a given data center, you ought to be on the lookout for duplicate IDs. So I guess in that respect, you could also fall back on that and say, well, it's no worse than if I clone the value out of the part. It's just a question of ease, right?
Yeah.
Where
yeah. I think we need to kind of set up like some guidelines, right? How to like kind of like a checklist. If this is to be secure, whether you're doing this way or that way, this is the list of items that like you need to ensure that are kind of there in the device to make sure that you're doing the right thing, right?
Yeah. How that part gets put into debug mode is also important, right? So if it takes someone to authorize going into debug versus just someone sitting out there on the planet, maybe that's helps with that problem. But in general, we should have guidance where you turn off as many spigots as you can turn off and make it harder. I mean, for that matter, we don't really know how these values are stored in a part. Someone could use external mechanisms to do observations within the part and go, oh well, I know the value now. I know how to copy it. Now I know how to make my own chips. So.
All right. So then, as far as one thing, I do not. This assumes self-generation, but I guess that's not gonna fly with all manufacturers, right? So we would say it should self-generate. And then if it injects, are there any, if it injects, then the inject's gonna have to come in here in another party, right? There's gonna be another player in this chart that shoots in the device ID and the keys, right?
Are you not assuming this in this ladder diagram? It looked to me like you're already assuming injection.
No, I said calculate the device ID and generate the ID in the device.
Why is there a left? I'm sorry, I saw the left-hand arrow of the ID device go out. It would seem like you wouldn't do that.
So you ultimately, the goal of this whole ladder diagram is to get this X509 certificate in there, right?
So why wouldn't you self-generate all the steps? I mean, to me, if once you've exported the ID, the value of calculating it is probably not too interesting. So to me, I'd want to generate the value. I'd want to generate a public-private key pair off of that. Then I'd want to export the attributes necessary for this certificate authority to sign it.
Right.
And then I'd want to import that X09 certificate back into the part. So the steps that you have from device ID, injection, outbound, down to I exported some public key material, I probably wouldn't do. Right, I'd say those two steps should be done within the part. I export the attributes I need to get signed, and I return the X09 certificate to the part, and I burn it in.
I don't know, I'm confused now because here's our device, our part that we're building, the tester device, and it's calculating its own device ID.
Right.
I remember it.
Yep.
It sends it out to the CA.
And that's the part I wouldn't do.
You wouldn't do that. You just bundle all of these pieces together and then send everything at once?
Yep. All within the part.
Well, that's fine. I mean, we can do that as one step at the end. But then all of these would still stay. I mean, they generate the key pair.
Yeah. You just wouldn't send them away, right? You wouldn't send the device ID outside.
Oh, I see. Okay, you're going to bundle it in the... Is the device ID ever going out? It's not a secret.
I would argue it should never go out.
Right?
Should never go out.
Oh. All right, because it's used as a seed, so to speak, for the...
Yeah, so I had put out, I'm delinquent. I never put the downloaded document that I put out there for the manufacturing process that sort of described this. Give me just a second. But I had presented some time ago some suggestions on how we would do this in the factory.
Mhm.
And what I ought to do is go deposit it in the repository and quit talking about doing it.
Okay.
So let me just share. It's not a ladder diagram like yours is. Yours is very neat and nice. Let me share my screen though, if you'll let me.
Stop showing. Oh wait, change presenter, I think.
Yeah, start sharing.
This is Jeff, right?
Yep.
Jeff, if you email it to me, I can post it in Drive for everyone as well.
Okay, that was Nate, right? Okay.
Yeah.
So Jeff, on the inject or generate, I think if generate is done correctly, it's a better approach. But done correctly is kind of key in that it's not predictable. It is off a good entropy source. You can have weakness in your generation from inside the part. So I think getting into that, whether it's generated or injected, I don't know whether that would be a separate document or referencing a standard on generation.
Yeah, I mean, we have, so clearly, first of all, can you see my screen or is it not showing?
Yeah, I can see it.
Okay, all right. So going back to this original diagram I had, my belief was ASIC should self-generate the secret, the UDS, or the device ID. You would generate within the part, nothing external from that pair, from that secret, private public key pair, and it would self-generate. And then you would export identity for signing by the HSM that's in the manufacturing facility. And then you would return basically the cert back into the part, and then you could ship it out, to whoever you wanted to. And every time you offered up your credentials, you would have your XO5 509 certificate that you could present. So in my suggested model, none of these items ever left the part except for whatever the identity needed to be to go to the HSM. So back to your comment, I think it was Brian was talking. Certainly, how this the device ID gets generated into the part. I think what you were getting at is I want some specs around how that's done, because you could,
or I think referencing maybe is something existent in terms of entropy for your generation, for that generation of that seed for deriving those keys.
Well, we could do like a NIST reference. I believe there's actually a NIST document that talks about how to properly generate a random value.
Yeah.
And what your sample size is for proving that you do it well. And what we could do is there's actually I think a CAVP test that they do on your parts for random number generation. And when you get your cert, it says, yep, you did it according to spec. Still doesn't mean that you in 100 million parts that you won't produce 2 with the same value, but you would hope to catch that, or maybe you don't because you don't care. But when it enters a person's data center, that's probably when they figured out they got a duplicate. And one duplicate probably doesn't scare anybody, but 100 duplicates showing up in a data center, you better go find out what happened. So
that's also the advantage of having your tied to your certificate or your identity is you can go and using standard PKI mechanisms revoke your trust
sure
in that device. You can do it offline without the device in your possession.
Absolutely. You could certainly pull the cert on it and say, well, I'm not going to trust that one anymore.
And then you can go an additional step and say, you know, you start to batch sign with Leaf or per device CAs that are signing that certificate, so you can have a lot of granularity on your revocation in terms of the identity.
Certainly.
So how specific are we going to get here? I mean, it seems like the more specific, the better, but are we going to say this, yea, verily, this is how you generate your device ID? This is how you generate your random numbers? Seems like that's okay with me, but we just have to know what we want to say.
It sounds like there's already documents describing how to do that. So we should just point at the NIST documents that already describe it and not try to rewrite them.
Right, of course, but the question is, which ones are we going to point to?
That's a good question.
So I guess somebody, I don't know who that might be, who suggested it, I guess, goes finds the NIST document. But the real kicker is, can you get a cert on it, right? And so what we could say is that for any given ASIC, you know, thou must go get a CAVP cert for your random number generator. And
so you can't get a cert on an entropy source currently.
I think there's a deterministic random number generator test.
Yes,
So run.
That you can get a cert on. So there's SP 800-90A and B.
Yeah. Yep.
So A you can get a cert on, B you cannot. So B is the, well, maybe I should state it differently. It's the random circuitry, if you will, that's actually producing the noise source, right? That's what they actually specifically call it in the SP 800-90B. Is called the noise source. You can't get a cert on that one. You can get a cert on SP 800-90A, which is the deterministic random bit generators. So that'd be the difficulty there.
Yeah. So the source of entropy, I think they've asked for samples of entropy during our FIPS testing, as I recall. Right. That you can do. You can go get your source of entropy looked at, and I think they download like I don't know, 10 million values, and they go, oh yeah, it looks like you got a good source of entropy. Thanks. Have a nice day.
Right. Yep.
So we could mandate for at least the generator, like you said, the 90A, and then we could do the entropy source test where we validate. That's a human inspection thing. There's not actually a suite for it, as I recall. So
yeah, there used to be one, but FIPS kind of made it obsolete. They had a suite for testing entropy.
Yeah.
In the past.
Yeah, I think now they just ask for a sample.
Mm-hmm.
So we could put that in the spec, but there's nothing to measure it against. We could certainly put the 90A and the cert for that in there. So.
All right, I took note of that. I can refer to that in the document.
Okay.
So one other question, Jeff, when you were showing your diagram there, the hash value that you were sending for, is that a kind of a fairly loose term, or is it something that I guess you already had like Elaine was asking earlier, right? There's two things I think she was asking about, right? One of them is, okay, do we want to be strict on the definition of what it means to have a random number generator? And I think we've already crossed that one, but in the other aspect is, okay, are we going to be strict on what it is that is going to be coming out of the ASIC for signing? I guess kind of in my head, I had this thought that it's going to be some sort of a public key, but it seems like you're talking about something else here.
Well, it could be a public key. When I drew it up, I was thinking about storage space and how it's represented and what you could actually sign or attest to. And I thought, well, you know, I suppose you could remove the hash part and just say, well, it's the ASIC identity plus the public key. But when I drew it out, I was thinking, well, a hash is probably even is an okay fingerprint also. And that you could offer up this hashed value because you know its size, right? And it's smaller. You know, it's kind of taken from the public key notion, right? So when we had talked about this in prior conversations, we had talked about storing the hashes of the public keys inside the part versus the public keys for space reasons. And you could actually store the public values external to the part, but you tie them to the part because you know the hash of them. So I'd kind of like taken that same concept and said, well, hey, if the public key is large and you have a storage constraint and you want to give up other characteristics, perhaps, I don't know, time or whatever, who owned it, then maybe a hash was a better thing to export and a better thing to receive. Because you can recompute those things. Now the problem with that is you got to have somebody on the other side has to have either be sent the hash or the giblets. So
Yeah, and every time you want the key, you'd have to ask it for the key and then go compare it to the hash, and then you could finally use. Yeah.
Yep.
Well,
it's not a hard. It wasn't like I was married to the idea. I was just like, oh, this is one concept that one could do. So does that answer your question?
It does, yeah. I think that's so. I think you have a fairly loose concept in your head. So yeah,
I have lots of loose things in my head, so it's okay.
But I think it's important that you have some sort of like a tie to the public key, right? That's, to me, that seems like it's a hard requirement out of it.
Yeah, I think you do. Yep, absolutely.
So if there's somebody out there that is really a guru with certificates who can create a draft of what our cert will look like. You know, what's the distinguished name, and, you know, with all this, where does it come from, and key usage, you know, because we're going to have some key usage restrictions, I would assume. What are we going to put for expiration dates? I mean, there's details that need to be in there, and we can either leave it up to the vendor or try to mandate or even recommend some things. But I can imagine that they'll come out really loosey-goosey and not very interoperable unless we specify some guidance.
Hey, that's a good idea, but they should almost never expire.
Yeah, I mean, that's one of the core tenets of the DICE spec, right? Is that the device IDs hopefully never have to change.
Yeah. But I agree with your concept that we should have, in this spec, we should probably have a 509 template that says these are the things that are mandated. You will include these. And, oh, by the way, you know, the cert has to be good forever, 70 years, so, or whatever. So let's make them all expire in the year 3000 and see what happens. So, but
yeah, make them all expire in the year 00. Only use 2 digits. It'll save space.
There you go. Only use 2 digits. Yeah. So.
Just calculating my lifetime.
I have more questions, so I can keep going on attestation here. This is a good discussion, but I need to get some more answers.
Sure. Go back to your screen. I turned mine off.
All right, I don't know how to get mine back again. I think somebody has to give it to me.
Okay, maybe I have to give it to you. I didn't realize that you couldn't just steal it back. All right. I have passed the baton to you.
I see it. All right, now I'm gonna go find the screen again. Oh, here it is. Yeah, okay. I see that. So I think we have answered my questions on the factory provisioning. Let me make sure here. So, okay, with device ID standard, we're not going to mandate that. We're going to let the vendor come up with what they want to do. The statement is, oh yeah, so we're doing this in a secure manufacturing facility. I think the consensus was yes. And and then the question about the 2 keys. I almost feel I feel guilty putting 2 keys in there, even though from a key usage point of view, I think they should be there. I just feel uncomfortable mandating that there be 2 keys generated and stored and all of that. It seems like an undue burden on the device.
What are the 2 keys? I arrived late, probably. What are the 2 keys?
So one asserts to the device's identity. It says, this is who I am.
Yeah.
This is where I came from. And the other is attestation for this is what I'm running and, this is how I'm configured. We could combine the identity into the configuration one, but it would have to keep presenting that every time. Right? That it's just part of its certificate.
So,
Well, I'm assuming the 1 key changes whenever the firmware updates.
Not necessarily. No. I mean, it wouldn't. No, because you're going to use it to say what the firmware is, but the key wouldn't change.
Right, but the second key we're saying says what I'm running.
Yes.
I'm running a different firmware, it'll no longer match the key that was the original device ID.
If your device ID is generated in part with your first mutable hash, yes, you're right.
Okay, so in that case, you would need the 2 keys, I think. If you were basing it on that.
Yeah, if you're going to base it on that. But then we don't force you to base it on that, right? We can let the vendor come up with whatever scheming they want to do to create the device ID. Well, how about this? If we make 1 key, so first of all, the device ID is going to stay secret, is what we discussed earlier. But the device ID is used to derive something. I'm not sure what it's deriving. And that something is then sent out to the CA. And what the certificate that comes back from the CA would have to include, if we just had 1 key, it would have to include the attestation public key in the cert. It would have to include some kind of identity, right? Wouldn't it then need to have the device identity in that cert? Some kind of reference to it that's unique?
Yeah, I mean, a key has to have an identity.
the public key is going to end up being generated as unique anyway, right? Because it's coming off the device ID.
Yeah. Yeah.
Right.
The question is what?
Effectively,
Yeah. So what's the concern about reusing the identity values to sign the attestation values?
If we had if we have the question was, do we separate the two functions? One of which is says so I think of in the case of a TPM, right? One's the EK that says, I am this device and I was manufactured by this vendor. It is not the same as the attestation key, the AK, which says, here are my PCRs or whatever it's going to attest to.
Yeah.
Two separate things. So do we need to maintain that model? This is who I am, and this is what I'm running. I mean, we could stick with it for now, and then, when people complain when they review it, I don't know.
Well, like in the case of the TPM, I guess I'm not an expert there, but what I vaguely remember them saying was one of the reasons they had multiple attestation keys was you use them when you're attesting to different, I guess, challengers, and you don't necessarily want the same one for every challenger, and so therefore you wanted multiple ones. But in this case here, I mean, it's the system there's one challenger, right, that's going to be requesting. So I don't know if that, would bear on this as far as the reason to separate them or have multiple or allow for.
I think part of it is also how many, like reuse. So, part of the concern is how many times do you use something? Does it allow somebody to figure something out? So one of the reasons they separate them is, I think, so that the attestation that can occur many times uses a separate key. And you could probably reinitialize the AK, I would guess, if you needed to.
You can generate an EK. Whereas the EK comes from the factory.
Yeah, I think the AK you can do again if you needed to.
Yeah. Okay.
So you could. Yeah, I don't think we made a lot of provisions for the thought of having two separate.
Yeah, I can imagine some vendors screaming. All right, I'm going to, in the interest of time, because I need to get to another question, and we only have 4 minutes left.
There's some really bad background sound, and somebody needs to mute.
Thanks. All right, so this one's a hard one, but we can just go through it quickly, because when I get to the ownership question, remember last week I presented 3 types of provisioning models: the imprint mode, transport key mode, or permanent keys in manufacturing. I personally think we're going to have to do something like imprint, or at least not specify. But if we're going to specify, there's too many problems when we don't know how many parts we need. We don't know who the owner is ultimately. There's or maybe we just have to handle protocols that have all 3 possibilities. Does anybody have an opinion on what provisioning model for ownership now? I'm not talking about the factory stuff. I'm talking about ownership that's going to control the firmware in this device. What model should we use, if any?
I would vote against permanent manufacturing keys for that, because that pretty much prevents you from being able to hand the device off to a second owner. Like, that second owner is now reliant upon you saying, or like promising that you forgot those permanent keys.
Yeah. Yeah. Anybody else?
Is the concept of a key ladder familiar to everyone?
Yeah, where you've got one that links to the other or certifies the other.
Unfortunately, I am not well versed enough in it to comment properly. But I know that one of the properties it gives us in Titan is the ability to transfer ownership or use different families of keys, like for development or testing or production, pretty fluidly. We can reassign ownership pretty well. The device has a factory installed secret and identity, but derived from that, you can make confident attestation in a particular context. So I don't think my comments are adequate to convey it, but is that something that is covered by the schemes you're talking about, or not?
In your case, then I'm thinking that you've got a permanent key in manufacturing, and then others can then take ownership based on that.
Well, there's I shouldn't go too far down filling in the gap, speculating over the gaps in my knowledge. But it does seem to serve our various use cases, including being able to reassign ownership without worrying about it too much at the beginning of the product's life cycle. Yeah,
I mean, we kind of have a hybrid, and it depends on which product we have. Some of our products we use imprint in, and others we use permanent keys in manufacturing. It sort of depends. When we really know that we're going to stay as the owner, we do the permanent. When we have no clue as to who's going to get either the spare parts or who's going to end up with the ultimate device, we have to use imprint.
Did Joe's content make it into the document for ownership transfer?
Joe's content in the, what was that?
Well, Joe had presented many weeks, maybe a month or so ago, ownership transfer concepts. I didn't know if it had made it into the document.
I don't think so. I don't remember, but I'll go look if I can find it.
Okay. We had notions of how we were going to enable ownership transfer. I
don't know. Send me a link, please, or unless it's out there in the wiki.
I'll test. I'll ask Joe if he actually added it, and I'm going to access the doc today and put in the one diagram that I said I would do.
Please. So. All right. Well, I think for now I'm going to go with imprint, and I'll look for what you have from Joe, and we'll go from there. It's easy, if we pick something and go with it, it's easy to shoot arrows at it. That's fine. So at least we have something to discuss.
Yeah. Sounds like we also need to research Ben's topic, which is how do you transfer the certificates from one CA to another.
Yeah. Ben, do you have a document that you can point to? Can you get us one?
We've got work going on. Actually, Nate can speak to this most directly as far as what we can release and what we can't. Nate, do you have any information on where we're at with opening things up there?
Okay. Seems like it ought to be public information about how to transfer a cert, but maybe not.
All right. Well, maybe you can put that in, get that back to us so we can study it and incorporate it.
Yep.
That would be helpful. All righty. I don't have anything else for today.
We're out of time. So, so that was very convenient.
I planned it that way.
There you go. All right. Thanks.
Yeah. Thanks, everybody. Good input today.
Yeah, thanks, everyone. And just a reminder for the agenda, Brian is up next week talking about Secure Boot. And then Jeff is up for Secure Update and possibly a DMTF security project update. So that should be our next 2 weeks.
Can we see those dates real quick?
What did you decide about Thanksgiving week? I thought we were not doing that.
Oh, I should go check the survey.
Yeah. I'm going to be gone on the 19th and the 26th. Or excuse me, the 20th and the 27th.
Oh, I was going to say good news. Neither of those are Tuesdays, but
Yeah, I was looking at the wrong thing on the calendar. So the earliest I could present material would be December the 4th.
Okay. I'll look at people's responses from the survey, and I'll send an email out with the update. But that was Jeff who can't present until the 4th, right?
That's correct.
Yeah, and that's the date that we were hoping to present the the other paper from IBM on the signing server.
Are you okay? Yeah, Elaine, are you okay going for the 11th then?
Yeah, we're kind of pushing it to the end for approvals though, because we're trying to get it through this year, right? Is our contribution our second one? So earlier is better.
Okay, Jeff, do you want to move down to the 11th then?
I can do that.
Thanks, Jeff.
Pushing out is never a problem.
Thank you, Jeff.
Unless I'm not around. That's a whole different matter. So.
Yeah.
All right. Yeah, I'll move people around on the agenda, and the agenda doc is open for everyone to look at anyway.
All right, thank you. Happy Thanksgiving if we don't have a meeting next week.
Yep. You as well.
Thank you.
All right.
Thanks a lot.
Bye-bye.
Bye.
Bye.